Hi there. I had this air compressor given to me by a friend. He's helping another fellow move, and he says that this compressor has rod knocker, wasn't pumping the tank up properly or something like that. So he gave this thing to me. This is my old clunker over here. Works pretty good. Doesn't really keep up to the sandblaster too well, but I figure this one might have a little bit better chance. And for free, well, I guess that's pretty good. So at any rate, it's in good condition. The tank is in really nice condition. It's got some overspray on it that just wipes off with solvent, I found, and some rubber marks, as we can see here, from it being dragged along, the bed of a truck with a tire and all that kind of stuff. So it was all together, and I told my friend maybe I'll take the head off and check the cylinders for scoring. He says, well, he says, this is my friend that told me this, so he says, don't go that deep just yet, He says, I'm not telling you that it has rod knock or anything. He said, just look around and see what you can see first, because I don't know how true that is. Maybe he misdiagnosed it, and that was a really good idea. And that's what I did. I took the thing, took the belt cage off here. I've got the belt cage sitting right there. And I found that the pulley, not this pulley, this is a replacement pulley, but the original pulley was loose on the 3/4 inch shaft, and it had about 90, maybe 90%, 95% sheared the key. It was just a hair's width from completely taking the key right off, and it was hammering that keyway for such a long time, or the actual key for such a long time, that it took the keyway right off the shaft underneath here. It smoothed right off. It hammered it right out, and then where the key stopped, at the end of the shaft, there's some keyway again. So I'm thinking, great, now I'm gonna have to weld this. I'll have to, maybe remove this bearing so I don't melt the seal, and put some weld in the shaft and grind it down and make another keyway again. So this is the old pulley here, and I don't think I'm gonna be able to get enough light for you to see the actual, how badly sheared it is. It even hammered the pulley out. This is a cast pulley. So at any rate, that pulley's in bad condition. And what I found really odd about this is that the set screw here, what it does, it tightens down on the key. It doesn't actually tighten on the shaft, it tightens down on the key. So any kind of movement in the actual the flywheel or pulley here itself is obviously going to get loose after a while. And what's even worse is this comes in on an angle. I don't know if you can see that here. I mean, look at that. They've screwed it in on an angle, so it doesn't even come in square. So just the corner of the actual the bolt that's running into this flywheel is touching the key. So there's really no contact area there at all. And that would be, obvious to the reason that this happened. So I'm thinking, wow, I can't reuse this pulley. So I went down to a place called Princess Auto, which is pretty much the same thing as Harbor Freight down in the United States side of things. And they had this nice pulley here. The pulley's just a hair smaller than the other one, not much smaller, and it's a shim style pulley. So what happens is there's a taper in the center here, and this shim has a collar on it, and it fits inside this pulley. It actually goes inside, and as you put these two bolts through, it pulls the pulley onto the shim, and that shim squeezes down on the shaft. And as you can see, you can't get it right tight. There's still a bit of a gap there, you can see. And on this other side, the shim is right flush with the edge of the pulley. I don't know if you can see that in there. Is right flush with the edge of the pulley and behind here. So it's as tight as it's going to get without me taking the heads off these bolts. And that with the remaining keyway on the back side here and the little bit of keyway that was left on the front here, I put this key in here, and there's no way that that's going to move. Like, this is part of the shaft. This is wedged in there so tight. And the nice thing about this is they actually have two little threaded slots or threaded holes here that you can take these bolts out and thread these back in slowly and push the actual pulley off the shim again. Because if you didn't have those there, it would be impossible to get this apart. It's on there incredibly tight. So that's good to go. So that's a really nice replacement, and really makes the repair quite a bit easier. As I said, I figured I'd have to weld the shaft and grind away with my Dremel and make another keyway and everything. But as I said, there's enough left in behind here. You can see the keyway in there. No. Maybe if I rotate it to the top. No. You see a little bit of the key in there. That's about it. But you can't see it. There's some keyway left in the back, probably about half an inch or so of keyway left, and then in here there's just a little bit on the end, probably about a quarter of an inch left in here, and then I put a new key in, and as I said, just use that and tighten it. So this isn't going to move. I'm almost positive that I could run this. You can see how it hammered you can see how it kind of hammered it here. I'm almost positive that this is never going to move. I could pull this key right out of here. It's so tight on the shaft, and I don't think it would ever come off. So I even ran, the thought across about, just tack welding this pulley onto the compressor, and I thought, nah, if I ever want to service it, that's going to be grief, and I don't want to, risk warping the shaft if I, heat up one side too much. So that's where I'm at with this, and so now this particular pulley here doesn't have any cooling in it, and that's a problem because you can see this one here has like a fan type structure inside it. So I've got some flat bar here, and I also picked up some angle iron here on my very messy bench. And what I'm going to do is take this fan right here, and I'm going to make a bracket and just mount it here so that it kind of sits away from the head like so. And the fan runs on 110 or 120, and as we can see here on the switch, we've got, this is obviously a 220 motor. This is about a real horsepower, about 3.2 horsepower motor. None of this 7 horsepower peak garbage. It's it's only a 10.3 SCFM at 90 psi. So it's not an incredibly fast pump, but it's much better than the one lung slug over here. It's been a really good compressor and dependable, and that smaller tank is probably twice as heavy as this tank. It's this thing is incredibly heavy. It's it's ridiculous. I can't even describe it. So at any rate, you can see here this thing runs on 220 as I was saying before. So I've got the red and the black going into here. This is my test cord running up to my outlet here on the wall. So what I'm going to do is that fan runs on 110 or 120, okay, and you can see this wire here. My camera will focus on my hand. You see this wire here. This is 120 from either here to here or here to here, right, because this is the common wire in the middle. So I'll run this to down to the compressor one. This is where the power comes in, and then the compressor motor runs off this tab and this tab down here. See those two kind of spade tabs on the bottom? So I'll run that fan to one of these and then to this guy here. And then when the compressor turns on, that fan will also turn on, and it'll fan the head this way here. I'd like to get it above the upper structure here so that it blows across the top fins here, and it also carries through here. The nice thing about the fin structure on this head is you can see it runs down and runs back up. So if the air is blowing, it's going to kind of guide the air up and in. That'll work really quite well. That way I don't have to, wreck the belt shroud and mount anything to it. And that's where I am with this. So I put a put a spout on here so I can use it for air. I've already pumped it up. The thing walks all over the place, so in order to stop it from walking, I went down to a local welding fabrication place here, and I brought some steel plate off them. They cut it for me really quick, and it's real nice. So what I'm going to do is, you can see I've got it under 1 foot there. I'm going to take these bolts I've got right here, and I'm going to cut. You can see here it fits nicely through that hole. So I'll cut it off about here, and then weld that to the plate. So I'll have studs sticking out, and then I've got rubber mat. This really thick black rubber mat. I'll cut really large rubber mat squares, and I have a sticky adhesive that I'll put on that rubber mat on the bottom side, and this will sit on the rubber mat, and that should stop it from walking, because this thing really does walk. It's ridiculous how badly this walks. You can't, I don't see any scoring on here. He's got overspray on it. You can see it just comes off really nicely. So this thing will clean up really nice. All this silly white overspray here. So I'll get rid of all that stuff, and you can see there's no scoring here or anything, so he hasn't really bolted it down, so I don't know how he had it mounted, the fellow before me. So he worked on motorcycles, and all that stuff. So at any rate, so that's the story on this compressor. It was free, and he says, here, take the thing. I don't know what's wrong with it, as I said. So it pumps up not bad. It's got very low time on it, and of course I got something else here too. He also gave me a little parts washer. So you see my friend there fixes motorcycles. At any rate, that's how it goes. That's where I'm at this point. I got the feet built. I welded a stud onto this plate here, and this is just a piece of rubber mat, and it sits on that. So you can see there's 3 little feet made for the compressor, and it doesn't really move around at all. It sits there, and of course it kind of jiggles on the mat, but it doesn't seem to slide off the mat or do anything. I was thinking of when I put these in, you know, where the old compressor is over there, I was thinking of actually putting some 3M spray on the bottom of these and just tacking them to the floor, and you know, that would definitely inhibit any kind of movement whatsoever. It doesn't really move at all right now. So I can't tighten these bolts up because I guess either the way that the tank has been sitting in the past or from vibration, this is a bit on an angle. So if I tighten this up, the plate kind of lifts on this one side, and it does it all the way around. So these are more right now just guide pins with a loose bolt and nut kind of sticking out. So I already have the belt guard back on, just to I was firing it up and stuff and holding a fan up, so I didn't want to risk getting my fingers in the belt, so I just put that on for now. So of course there's no air cooling going on this thing whatsoever, just because the new pulley has no air cooling. So what I've done is I've got some pieces of steel here, some angle iron. I'm just tapping them right now, and what I'm going to do is, you can see this one over here. You see this one over here, I'm using this as a guide for the fan. So I've tapped these, and these are just, it's held on there, and I'll mount it to the other one. And then this is going to sit here on the compressor. I know this is kind of dark. See if I can up the exposure just a little bit here. That might help out just a hair. So these are going to sit here, and then this will sit on the top like this. And I'm going to weld a tab that sticks out from here, and then I'll weld it onto this angle iron, and that'll hold the fan here. And then I'm going to build a small fan controller. So what it'll do is the fans that I've got are 120, and this is, of course, this machine runs on 240. So what I'm going to do is with the 220 or 240, whatever you've got, it's closer to 240 something here, 245, goes in here, and then it gets switched to these guys when the pressure switch turns on. So it connects one side to this guy and one side to this guy, and that runs, of course, into the motor. So I have on the wire, I'll just run the neutral wire in. So we've got a red, a black, and a white. So the red and the black are 220 end to end, and the white is 110 to either side, or 120 to either side, okay? So I'll use the neutral wire and one of these guys, which is unswitched, and a switched wire. And I've created a small circuit I'll probably mount right here. And what that'll do is, when the compressor kicks on, it'll turn the fan on, and the fan will run as long as the compressor is on. And then when the compressor shuts off, the fan will stay running for about 5 minutes, just to cool the head off and to make it a little bit easier on this compressor head. And then it'll shut down, and every time the compressor kicks on, it'll turn the fan on, and when this shuts off, it'll remain running for about 5 minutes and then shut down. And I'll get into that circuit in just a little bit. So that'll take place of the old crappy flywheel there with the kind of crooked set screw in it, and then keep this guy nice and cool. So it takes the pressure gauge here. See if I can get this into the light. It goes down to about 75 psi or so, and then it kicks on, and it pumps up from 75 to about, maybe a little over 125, 130. I think it's about 130, yeah. These are in fives, right? 30, 35, 40, 45, 50, yeah. So about 130, maybe a little over 130 psi in about a minute and 20 seconds. So that's as long as it takes. When it got warm, it took about a minute and 22 seconds. So that's not too bad. and it's pretty consistent. So, you know, from down here, I noticed that, you know, it seems to pump up to 100, you know, a little over 100 rather fast, and then it slows down as it gets to 125. And of course, you know, it's doing some work up there, so this pipe is absolutely blazing hot. And the top half of the tank gets hot from the air coming in, and it really does. It's the top half of the tank is warm, and then the bottom half of the tank is cool, so it's really pumping in some hot air through that pipe. And of course that doesn't help. And then of course when the tank cools down, I've noticed that the pressure drops down just a little bit. You can see I haven't drained it at all. It's just a little bit below 125, and that happens within about 20 minutes or so. So you lose a bit of pressure as the tank cools off. So obviously it's there is a temperature affecting it, or the temperature's affecting the meter or something. So that's where I'm at this point. Well, I just finished welding up the bracket. You can see here there's some feet that mount to where the compressor is bolted down. It actually sits on the compressor itself, you'll see in the future video. I welded some tabs onto the side here, and I also welded another piece onto the front and made kind of like a cowl. And what that does is that directs the air above and around the sides of the cylinder. So that way it directs it a little bit better than just kind of fanning out into the middle of nowhere. So that's the bracket right now. It's just been painted, and it's just a satin black on it. It's probably a little bit hard to see, but try and get it into the light. So you see I'm not too worried about a little bit of splatter from the arc welding. I just left it on there. It's just going to be on a compressor that's in the garage. So there's the weld. And I just welded each side of the top there just a little bit, and it also bolts. You can see that hole; it'll bolt onto the head so that it gives it some structural stability, so that it doesn't shake too bad. That the whole unit really shakes bad, and of course that's the reason for these feet on the bottom on rubber pads, because the compressor really does walk. So that's where I'm at right now. Okay, I've got the fan mounted on, and it's running right now. You can see here the cowling is going lots of air. Lots and lots of air is coming through here. I would say way more than from that actual flywheel. And on top here, you can see it's blowing across the pins. I need a piece of paper or something to show you guys how well that's working. Alright, grab some of our Canadian Tire money. Kind of hard to tell even with this. It's blowing hard. I'll just blow it away. But at any rate, it's blowing really hard. Lots and lots of air. As I say, don't think the flywheel produced that much air. And it's really well directed. I can feel it's traveling on the fins. And if I go over onto this side here, you can feel it coming out of here. So it's working really quite well. So there's the little cowl on the top, and this is the little screw that goes into the head there, you can see. So this is really quite sturdy. When I welded it, this did take a little bit of a twist. It's not too bad though, everything's still mounted up. And of course when I tighten it, it doesn't really help, but everything mounts just perfect. And it's, you know, fan fit on perfect. And I threaded the holes into this angle iron here, so I just slid these long screws through, and they just thread right into the angle iron. And they're nice and tight. So it's working quite well. So this is just plugged into the wall right now. I haven't got the actual little circuit made that does the timing and all that. I'll do that next. So I'm beginning the build of the fan controller circuit. I've got this aluminum box here. I've already marked off some little dots for some LEDs here. So I figure I'm going to mount this about here, like so. And that will control this fan up here. So I've got a circuit already designed, and I'll show you that circuit here in just a moment. So this This little box will have a little wiring harness that'll come out of the main relay box and go into here, and I'll have this monitor a bunch of different things. It'll probably have it'll monitor, say that there's actually 200 volts on here, because I have a bunch of switches in the line with this thing, that outlet up there. So it'll tell me that 220 is present, and the fan runs on 110 or 120. This should actually be called 240. So 120 and 240 here. So this one will be a 240 lamp, and this will tell me that the 120 is present, because without it, of course, this fan won't operate. So if the neutral line ever goes missing in the box, of course, the cooling fan won't work. So that'll just monitor that. And one will just tell me that it'll have a lamp to say that the relay is on, and one will have a lamp to indicate the cooling, so that the actual cooling is operating. And yeah, so I figure that's what I'll do. So we'll go check out the actual schematic on the computer. I designed a small controller circuit last year for a fan and an amplifier. It was a ViewStar ham radio amplifier. It had a 3500 Z tube in it. And I designed this fan controller here in order to keep the fan going in case the operator of the amplifier blew the fuse inside the amp. This would bypass that and keep the blower running for about 5 minutes. And also in shutdown, when you shut the amplifier off, the filaments go off, and the glass case is really, really hot. And so this here will keep the fan on for about 5 minutes or so, and then automatically shut it down. So this is the little circuit board. I just made this right now. Just, you know, took that off the computer again and made another board. So it's a very simple circuit. It uses a zero-cross triac right here, or on the screen right here. And then the triac sits here. It's a little 555 timer and a bunch of resistors and such in order just to you know, create a small timer. There's a transistor down here, which is a trigger, which goes to a sense lead over here. This is a sense lead. This is line and hot. And then here is neutral and hot. This is continual neutral and hot. There is no break in this line. So this one here is intended to be switched, as you can see. So this this neutral and this hot have a resistor coming off of it. I think the last one I use is about 1.5K at 20 watts. It stays warm all the time, but it keeps power to this circuit board. Now I changed the design of the circuit board just before I built this. I had it originally driving a relay instead of a triac, so the it might actually, I might be able to up the resistance. It regulates it out to about 13.5 volts or something like that that 555 runs on. And you know, that's just kind of the circuit in a nutshell, really quick. So just a timer that when the sense lead goes low, there's a rectifier in here, and it just, you know, basically drops the 2N3904 out, and then allows this thing to time out. And then the opto, eventually the zero cross opto shuts off and shuts the triac off. So I'm just going to use this on the compressor, same kind of circuit, just a couple of little variations. I'm going to add some LEDs to the box to show that the 110 and the 220 is present, and that the you know, the compressor's on and all that kind of stuff. The reason I chose to use a zero cross opto is in the radio circuit, if you use an opto that doesn't fire at zero cross, it makes a lot of hash and noise in the receiver. So running a zero cross opto in any kind of radio circuit really does help with the with keeping it quiet. So this little board here is just a toner transfer method. I've been doing this for a while. I've made a customized laminator, and that's what does these. They come out really quite nicely. You know, I can, you know, solder some. Well, this is all surface mount in here, and of course there's going to be some through-hole components that sit on this side of the board. But it really does quite a nice job. I will in the future do an actual video on how to make circuit boards with the toner transfer method. As you can see, like, I mean, it's really, you know, the traces on this are just, you know, really clean. I can go quite a bit smaller than this too. I go right down to a 402 with no problems. So this is you know, these are 1206 parts and stuff like that, so it's really, these are big surface mount parts. So that's where I'm at this point. I'm trying to figure out on the pieces of paper here exactly how I'm going to use this terminal tie strip here in the box to tie the LEDs and the resistors to. There are going to be some wattage dissipating resistors here, so I'm going to suspend those, and you know, the box will get just a little bit warm, but I've just gone through just trying to see how I can tie it together, because it's all about planning. I think the circuit board's going to fit in this corner of the box. There'll be a hole here where the wires come in, and then on the front you can see where I've kind of center tapped, or not center tapped, but center punched some spots for some LEDs. And then of course this board, this isn't trimmed up yet, I have to trim it up, and then that'll fit down in here. And the caps I'm using are this kind of style. They're shallow, they're FC style, you know, really good capacitors. So they're a smaller kind of cap, and that should be able to give me some room, you know, between the lid. Even the lid, do I have the lid here? I do. Even the lid kind of has a bit of an indent in it, and it stands up. So this is really not the lid. The lid's up here, so I'll have some fine clearances. And since this compressor shakes like crazy, it really does. It walks along the floor. I'm going to probably use some silicone in here and just silicone the capacitors steady and all that stuff inside the box, because it's going to just get, you know, shaked really hard. So that's another reason that I don't want to attach a relay to this particular part of the apparatus. It's a small relay, might be a little bit sensitive to the amount of shaking that's up there, and it really does shake quite hard. So that's where I'm at this point. When I get some more stuff done, I'll add to this. Okay. So I'm ready to drill the board here. You can see I've taken all the toner off. That's just acetone, wipes that right off. I haven't plated it yet. I also tin plate the board, but I drill all the holes first and get everything happening before I do tin plate. This little drill press that I've kind of added a couple of custom things to. You can see this little lamp here, and there's also a lamp down in the hole so that I can see the holes much nicer. You can see how it illuminates the holes where you're going to drill. That really helps out when you're making circuit boards. So what I do usually before I get started with this, and I'm surprised I haven't made a sheet of paper yet, but I take the components like the optos. I'll go over here and grab an opto, say out of this drawer. These are non-zero optos, but what I'll do is I'll mic the pin on the opto, and or I should say use a caliper on it, and measure the diameter of the pin, and then I'll choose the appropriate bit for the actual hole size here. So I should have this written down on a sheet of paper, and I did at one time, but I don't know what I've done with it. So I just I have so many different projects, and then I use different wire sizes. You can see these pads here are pretty big, so you know, they're designed to take a fair size wire. Now there's going to be that junction strip in there, so I don't need to worry about running the 16 gauge wire directly right into this board. So I'll probably use a little bit thinner wire. And then of course these here will be tapped to machine screws, or drilled out to the size of the machine screw that I use, or the standoff, whatever, and on that. And these are the little bits that I use, little titanium bits. And it's very important if you ever want to do circuit boards and you do buy one of these Dremel presses. You can see it. It's a nice little smooth Dremel press. I broke a lot of my titanium bits just from this press right out of the box, this Dremel press. And what happens is this drill in this cup doesn't sit square. So you can see I've added a shim down in here. I don't know if you can see that little tab stick up, that little shim. The drill, when it was actually not straight, because this cup isn't sitting completely straight, and it would snap all my small bits. And I was wondering why. I thought maybe the bits were just, you know, very fragile. And then I realized, hey, maybe this isn't sitting quite square, because you take it for granted. You buy a brand new press and it should be square out of the box. Well, they aren't. So if you ever want to use titanium bits, make sure you get a square, and make sure that your bits are square under here, or you'll snap all your very small bits. Like these are extremely small. They're the size of a pin. So I have quite a few left, and I'm always looking for more. I think they're available on eBay and from hobby shops and stuff. So I'll probably go and refresh my my bit collection here pretty soon. But I've got all sorts. I've got lots of different bits up here and all that kind of stuff. So this is what I'm doing right now. After I get this done, I'll plate it, and then I'll start populating this board. And I got to cut it up. What I usually do is I've got a you've probably seen from the other videos in the garage there by the compressor, I've got a small bench grinder. One of the wheels turns very slow, and what I do is I hold this flush up to the edge and kind of use it as a plane, and then I'll plane it right down. These are just little guide tangs, these things right here and here, so that I can cut the board square. So I include those on all my boards, and then I get a nice square board in the end. So there we go. Okay, so the board's all drilled now, and I'm going to tin plate it. And I use a product here called Liquid Tin. It's made by MG Chemicals. It works very well. I'm trying to get the copper the best I can into the light so you can see it take place. So it works very fast. I hope there's enough light here. I don't want to splash it on my camera either. See how fast that is? It's already tinned. So that's how this stuff works. Works extremely quick, and it tins your circuit boards and protects them from oxidization and makes it easier to solder and all sorts of things. They say it makes it easier to solder on the can. I find that raw copper solders pretty nice, but this stops it from looking bad in about a few months when the copper starts to change color. Of course, there's the option of coating the circuit board too with a spray. I bought a case of that made by CRC. It's a red colored spray, but it makes your circuit boards look pretty ugly when you're done, but it preserves them. So hopefully you can see that okay. So I'll let it sit for about 5 minutes just to make sure the plating is thick, and then I'll drain the stuff back into here again. Now this stuff is pretty caustic, you got to be very careful. So I'll have a little funnel here, and I'll take this and I'll drain this all back into here. As you can see, I'm using gloves. So that's how that goes. This here is a circuit board machine that I use my laminator, my modified laminator, and I've designed a small circuit in there that modifies the temperature, and it's a fan, and anyways, yeah, it's about 200 degrees now. It's a pretty hot laminator. A little squirrel cage on the side to cool the gears. The gears on this side are plastic, so I figured I'd better do that and block that area off. And this is just a power tranny for the laminator, and you feed the stuff through this way and it comes out this side. And that's been my laminator for years. So one of these days I'll go over all this stuff, and I'll show you how to maybe build the laminator and also make easy printed circuit boards just right off your laser jet. So there's a couple of little tricks that makes them, that make them come out just, this nice. So I'm going to end up populating this now, and then once I've got it populated, I'll show you how that goes. Okay. I'm ready to start populating the board here. I've got the board under the microscope, and I'm going to start placing the little components on. I always start with the surface mount side first because it gets really difficult if you populate this side, then it doesn't sit flat. This stuff is really nice. It's kind of a rubber mat, or some sort of a sticky kind of mat. It doesn't actually feel sticky, but when you're using the tongs and you're putting parts and pieces on the board and soldering with another hand, this thing wants to move around, right? So this mat is kind of nice, and it holds it nice and steady while you're doing that. So that's all that is. I have this in different sizes, and of course I'm using my just regular Hakko iron. And I always use RA flux. I'll dab RA flux onto the board, and that makes it solder extremely fast. And then if the tip just has a little bit of tin on it, or a little bit of solder I should say, it'll work. See, clean that off there. See, I use this hooked sort of tip, and that really makes it easy to get into. And you just hold the with my other hand that I'm holding this camera with, I would be holding the tweezers, and I just hold the part on and then touch it with the flux, and the flux wicks the component right down onto the board really, really quick. So it really helps the flowing of the solder. So this is the point I'm at now. I'll populate this entire board and come back with some more. Okay, the board's populated now. You can see all the little parts on it, and on the top here. You can see all the little components. The track is right here, and the zero cross opto is right there. I'm using the Nippon Chemicon, or United Chemicon capacitors. The code on this one is LXY, and the other one is a KY. So they're both 105 degree. They're really good caps. So this one here is for the timing. So yeah, it's just about ready to rock and roll, this one. So next I'll be putting some wires in the circuit board, and I'll try and fit it in the case, and that's where I'm going to be next. So far, I've got the circuit board in the case with a terminal tie strip and another little tie point down there for the resistor. And I've got the holes drilled for the LEDs and the big hole in the back end for the grommet where the wires are going to come in, and another terminal tie strip. That's what those holes there are for. So this is what this is where I'm at this point here. I put a piece of paper, fire retardant paper, underneath the circuit board there, and there's also a little dot of silicone under there just in case down the road from vibration or from heat the board tries to warp in at the center so that it won't try and touch the metal case. It's close. It's probably about I'd say, you know, the clearance between the solder blobs on the bottom and the paper are you know, probably the thickness of another maybe 2 FR4 boards. So it's not very far away. It is actually pretty close. So that little silicone dot right underneath this KY cap here, kind of the center of the board, will you know, will harden up and keep it from bowing in at the center. And then of course there's paper under there just for a little bit of extra caution. So that's where I'm at this point. I just finished painting the box and adding the notations to say what all the little LEDs do. You can see I've added them, try to get into the light here the best that I can. You see one says fan on, compressor on, 120 OK and 240 OK. And I just painted the box kind of a off-white ivory color. That's what this labeling seems to work the best on and blend in. So the box has been painted. This is just with Krylon spray paint, and it's an ivory colored Krylon paint, and then it's been coated with a clear lacquer. And that's where I'm at. The circuitry's inside. There's a couple things I've left out. You see the screws that are mounted to the top here. The screws hold in a circuit board inside, and some of the standoffs, and that nut that's on the end there is also holding some wires and stuff. And I put the bare necessities in the box. The reason being on the face is that when you freshly paint a face and you tighten screws down onto the face, it usually either squishes the paint out, creates bubbles, or cracks the paint. So I wanted to get most of everything onto the face and then do the labeling and the actual spraying of the face. So there's still a couple of screws I haven't you know, got in. Those are on the side there. Not really, oh, they will be viewable, but not directly, you know, not directly viewable. And then of course the rubber grommet and all the wiring will go in once the paint is hardened up and the clear coat is hardened. So I'm hoping that on my screen it's looking really small. I'm hoping that's in focus. So I'll chase the holes tomorrow with a bit and then put the LEDs in, because the holes are now, they fit the LEDs just perfectly. You have to press them through the holes in this aluminum box, or I guess it would be a cast aluminum box, and so the paint and the clear in the holes will stop the LEDs from coming through. So I'll just chase the holes with the drill bit tomorrow, and then I'll press the LEDs through. Alright, I've got the circuit board mounted inside with a resistor. This resistor here is 1.8K at 20 watts. It does get a little bit warm, but it's heat sunk to the shell of the case here. Not hot, I would say, it just gets warm. And this is JB Weld glue. This is the quick stuff, works very well. It sets in about 15 minutes and it's rock hard. And I've installed the LEDs here. You can see the LEDs. I've also put just a little bit of JB Weld on one side of the LEDs just to hold them in. They, just due to vibration, the LEDs themselves, they press fit into the aluminum case with the bit that I've chosen to work with this particular LED. So they are tight, but that's just a little bit of extra precaution. As I say, this thing is shaking pretty bad, the compressor. So over time, I don't want this to come out. And this build I intend to last for an extremely long time, so I don't want to go back in there again for years and years and years. So this will be you know, I'm hoping that this will be the final go, and I won't have to worry about that anymore. So this resistor, one tie point is here, and then one is at the end here. I've got a couple wires attached already, not all of them. As you can see here on the face, I've got the LEDs. They're already poking through. So that's working out okay. Everything is good. The paint is still a little bit soft, and I'm kind of pressured to get this done because I need to use the compressor. So made a couple of small little marks here and there. That's from my wire cutter right there. That's what impatience will do. So it doesn't matter. Just if I wanted to fix it, I'm not really too worried about it because this is just going to be hanging out in my garage on my compressor. But if I wanted to fix it, just a brief little wet sand and a touch up with some clear would completely fix that up. That little mark there, I don't know if you can see that in the camera. That little mark right there is from this handle, just sitting on this handle. So it's sat for about probably 16 hours already, and it's still pretty soft. There's a lot of clear coat on top of it. So trying to make the sticker blend in and work very well. So it turned out okay. I'm very happy with the result. And so now I'm going to attach all the wires inside here. And there's still quite a bit of clearance to the shell. You can see here, if I move this up this way, you see the other. If you can see the other side there, that means that nothing's poking through the lid. And I can still tilt it, and I just start to see the caps. So the top cap itself doesn't sit flush with the top. It's actually raised above just a little bit by the in here. So you can see that the lip is down here, but the actual top is inset further. So there is a lot of clearance. What I will do when I put this together is I will put another piece of that paper in here, and I will also put dabs of silicone on the capacitors to stop vibration, and I will also put some silicone on this triac here so that the triac doesn't come loose, you know, from shaking, or the solder joints don't come loose. When I drill the holes in the circuit boards, the holes are very tight around the components, so I doubt it would ever come loose anyways, but as I say, a little bit of extra precaution can't hurt. So everything in here is, you know, really overrated. These Zeners don't even get mildly warm. This resistor here does get warm, not hot, but it does get warm. And yeah, like everything in here, this 10K resistor here is just gets mildly warm too. So everything is really, really overrated. There's only 13 volts on this cap. Originally I was going to use an FC, which is the same size cap, but it had a 16 volt rating. So when this is off, the board sits at 14 volts due to the Zeners. And so that's kind of close to 16. I don't like that area, so I put a 1000 mic in here at 35, and there's enough filtering there, and there's a big voltage gap there, so I'm happy with that. And same with the KY style cap here. The 470 is a 35 volt cap, so the voltages are greatly exceeding, you know, what the running voltages of this board. This here is just a little snubber network down here for the fan. Doesn't, you know, like, I mean, that fan is not a very big load at all. I don't know how much current it pulls. Do I have one here? No, I don't. I thought I had one at the bench here. I could tell you how much current it draws, but nothing major. So probably unneeded, but just a little bit of extra precaution. And the tantalum is running it at a reduced voltage here. This is just for the timing down here. I could have used a surface mount and done this, but this I designed this board years and years ago, and with the junk box parts that I've got, this is the stuff that I chose. And now I've got lots and lots and lots of surface mount equipment. I got you know, I got tons and tons. It goes on and on. There's surface mount stuff everywhere. You know, up on the top, up on the top up there, I've got lots and lots of surface mount stuff. So I don't really need to worry about using through-hole stuff anymore that much, but this was already designed and reduced my build time quite effectively, so I just went with what I've got. Okay, all the wires are put in and it's ready to get wired up. All these wires go off to the fan and to the relay, and you can see all of the wire connections are made. All this heat pipe, the resistors are inside here, so they just don't touch adjacent parts. And we can see we've got a resistor here that does get a bit warm, so I used a piece of heat pipe here, and the wires just get route through that. So there's no silicone been added or anything yet. You gotta pre-test the system before you really make anything too incredibly permanent, just in case there is some wiring error. But it looks like everything is okay. So the next step is to go put this on the compressor and to test it out. Okay, I've got the unit all done, and I don't really have the plug hooked up yet because I have to move it into the corner. This is just my extension cord, and this is the neutral wire here, or we could call it the center tap on the transformer outside, whatever you want to call it. I draw schematics, so I look at this as a center tap to the transformer on the pole, and these are the two outer legs. So this is 220, and then of course it's 110 from here to here, and then 110 from here to here. So that's how that works. So I'll show you how this works. I'll plug this in. I'll just show you a couple of features before I actually turn it on. Well, we can see that there's two lamps glowing now. If I zoom into this, you see the two lamps that are glowing here are the 240 and the 120. And that's really handy in my garage because many times I come out here, I have a breaker in the other room, and I shut the breaker off to the 220 and to the garage supply. So I've been sandblasting before, and the compressor doesn't kick on, and I'm wondering what's going on. It's like, I forgot to click the breaker again. So this tells me that there's 240 present, which is kind of nice. This 120 is important here too, because this fan that's up in the top corner here, this fan, if I can focus out sometime this week, this fan here, slow focusing camera, this fan that's now cooling the head of the and the cylinder of the compressor runs on 110 and or 120, and if that 120 goes away, I have problems. So the fan will stop and everything. So if I remove this neutral wire, this is the neutral wire here, you can see that. So if I have a neutral fault, I lose my 120 down there. So let's zoom on into that. And you see, so if there's ever a fault or a problem, or something goes wrong, I can see that my fan won't turn on. So it's just a fault indicator, really. So I'll just slide that back on there again. So that's how that's working. As I say, I haven't really done any wiring, hooked this thing up yet, because I have to slide it into the corner where the old compressor is. The compressor comes on when the motor is on. So that would indicate an issue if the motor wasn't starting or something went haywire and the compressor light came on and the motor didn't start. I would know that there's power applied to it and the motor's just not running. So again, another little diagnosis thing. And the fan on is just a light that indicates the delay for the fan that's up the top there. And the fan will stay on for about 5 to 7 minutes, I guess, something like that. And it wasn't really timed out. It's just a random value I had written down on the paper, and of course it changes with various resistors and all that kind of stuff. So just ever so slightly changing the resistor really affects the time with this little circuit. So that's why I use tantalum caps and everything in there to keep the timing pretty precise. At any rate, about 5 to 7 minutes, I'd say, the fan up here will remain on, and then it'll shut off. So that's how that works. I'll show you how this whole thing works. I got to drain some air out of the tank, and that's extremely noisy. So I'm going to shut the camera off, and I'll drain the air, and I'll get it just about to the point to where it kicks on, and then I'll kick it on. You'll see all the lights come on, and I'll kind of do it in just short little brief clips here, because it takes a bit to pump up and a bit for the fan to shut off. Okay, it should be just about to the point to where it'll kick on. It's just under 100 pounds. So a little bit of air out with the nozzle on the other side here. You hear how noisy that is. Boy, that sure takes a long time. That needle isn't moving. I'll pop the other valve here again, and I like that. Lots of air reserve. So I'll pop the other valve again. Okay, so we can hear it starting. You can see all the lights are on. Let it get just about to the point of being off, and then I'll turn the stop on. Okay, we're just about ready to shut off. So we can see now that You can see now that the compressor's off, the fan's still running. That's this guy up here, still running right now. Got lots and lots of suction, and it actually cools the cylinder off before the fan. Like this tank can pump up from dead, no air in it, to completely full, about 130 psi. And the top half of the tank is really hot because the air that's been pumped, the compressor's really doing work. It's been on, it's pumped the tank up from nothing. So the top half of the tank is really hot from the air, and then the bottom half is kind of cool. And by the time the fan shuts off, it's about 5 to 7 minutes, the head is not even lukewarm. It's just barely even warm. So this really works well. It works much better than the actual factory fan on the flywheel. Now, of course, the factory fan stops when the compressor stops, or when the motor stops, so there is no more cooling. Whereas this will stay on and keep fanning it. So that's how that works. In about 5 to 7 minutes, this guy will just shut off on its own, and that'll be it. Okay, should be getting ready to shut off pretty soon here. I'm not sure, I'm just going on a whim here. I didn't get my timer out, so there we go. So there it is, and it shut off on its own there, and it's just ready for the next use. So the next time the compressor turns on again, everything comes on the compressor, and the fan will come on at the same time, and the fan will do the same thing around for 5 to 7 minutes or so, and then automatically shut off. You can see the head is it's absolutely dead cold. I'm putting my hand right on the cylinder. It's not even warm really. So it does a really good job. That fan really cools it off quite well. So as I say, the wiring is still a little bit botchy right now. I still got to get in there and clean all that up. But I have to do all that when I get it in the corner, because I'm going to probably size up the cord and fasten it to the wall and do all this kind of stuff. And I have to get the feet and move everything and get everything all perfect. So I'll just leave the wires like this until I get the thing in its correct spot, and then I'll clean it all up at that point. I think that's all I was going to mention about this. The box itself is held on by the 4 screws on the back. The cover is on the back of the box, and there's 4 screws that run through this plate here. This is a little bit has a bit of a temper to it, this steel, so it's a little bit fun to drill, but not too bad. Put 4 little small holes in there, and then that mounts to the and everything's lock washered and because of the shaking of the compressor. And there's the silicone in there, and that paper on the back there, and lots of clearance to go. So this could just be left on 24 hours a day. It'll just indicate 240 and 120. Those 2 red lights will be on, and I'm not worried about it. The thing will it can be left on, or if I feel like clicking the breaker off, I can do that. That resistor that I was showing you that I mounted into the box is up here, and the box gets barely lukewarm. And the 4 resistors that are in series with these LEDs, there's 2 on all the time, and they just get just lukewarm also. So the whole box is really quite conservative in its design, and when I build something, I build it to last. I don't want to have to go in that box ever again, and that's the plan. So this is the last time. I fixed up the paint on the box, and where I smudged it a bit with my fingers. I let it set for about, must be about 9 or 10 hours anyways, and it was still soft because there's lots of clear on it, but I touched it up and all that, not as if it really matters. It's on a compressor, and it's going to hang out in the garage and probably get looked at every time I go and use my sandblaster or something like that, or when the thing kicks on, I might glance over it to make sure that the fan's on, that kind of stuff. But it's it's definitely not a thing. It's not supposed to be a thing of beauty. It's just supposed to be a utilitarian thing. The tank, talking about not a thing of beauty, I cleaned all the overspray off the tank, so I couldn't handle that. I had to wipe that off. So I cleaned that all up, and so that it looks pretty much like a brand new machine. It's got a couple of little scuffs here and there, but other than that, it's in relatively good condition. So as I say, this is its probably one and only cleaning. Maybe it'll get wiped down from now on here and there, but compared to my old compressor, you can remember in the other shots there, it's right behind the camera. It's that old compressor is got more gunge and grime on it than you know, well, it has a lot of grunge and grime. Let's just put it that way. It's disgusting. So I should wipe it down, clean it up. I'm going to offer it to my neighbor. He's a really good guy, and see if he wants it. And if not, then I'll probably just, I don't know, throw it in the Craigslist or something like that. Get rid of the other one. So there it is. Hope you enjoyed this little episode of welding a fan motor onto my compressor and making a little controller for it. A little bit overkill, but I don't know. I couldn't find a flywheel with a fan on it, so I figured this is the next easiest thing, and it really didn't cost me anything. The box I had here, the fan I had in my junk, everything I had here. The only thing I had to go out and buy is the angle iron, and that's what costed the money, just the angle iron and some flat iron. And that was really it. Everything else was right here. I got a bag of these LEDs, probably about 1,000 of those LEDs, so I just dipped my hand in the bag and grab 4 and push them in, and everything else, as I say, is right here. So it's a relatively cheap fix, probably cheaper than actually replacing that flywheel. I had to, of course, buy a replacement pulley, but that replacement pulley wasn't all that cheap, but a way better solution than what was on the machine, as you can see with the sideways set screw. Ay, ay, ay. What are they thinking? I have no idea. Okay, hope you enjoyed. Bye-bye.